Hello, this is your introduction to Linux 32-bit reverse engineering. And basically, the synopsis of the course. So this is a course roadmap here, and the first section of the course is going to be an introduction to reverse engineering. And what that does is cover the foundational concepts of Linux and then the x86 architecture and file permissions that are used for Linux. So it's a breakdown of x86. We go through the Linux ELF file makeup, the SUID and SGID fundamentals for like permissions, and then just give you a overall understanding of what x86 architecture is and the structure of that, and then kind of talk about what reverse engineering is. So in section 2, we're going to be setting up the lab environment. This covers how to set up a lab environment to practice and perform reverse engineering. It's a very important part of the course because basically I walk you through the concepts of how to set up a lab that will allow you to do these things without breaking any computers. It gives you the environment you need to actually analyze and perform the reverse engineering tasks, and then set you up so that you can take the course and use that in the future to dive further into this topic. Section 3 is shellcode fundamentals, the foundation of shellcode concepts and how to create and use it. So basically, shellcode is, how you, it's code that's, the exploit code itself that allows us to get a shell. And part of that is being able to do the exploitation phase. So give you the background knowledge so that once we get to that part of performing some of these exploits, you know how to do that. So it's catered to, even the newest people taking the class that are new to these concepts. And then in section 4, we have format string flaws, where we will be analyzing, identifying, exploiting, and correcting these flaws. So it's just basically breaking down format string flaws, analyzing the source code to identify them, delivering payloads, and then exploiting the format string flaw itself. And then in section 5 is going to be the buffer stack overflows. A lot of times it's referred to as, buffer overflows or stack overflow. You'll hear it called multiple things. It's a foundation of what buffer overflows are and how to analyzing and developing exploits to perform them. So basically, this one's one of the really fun sections of the class. So everything kind of builds up to that with the first areas, and then it's one of the longer portions of the class as well. So you look at the anatomy of a stack overflow, what it is, creating a vulnerable application, and then a technique to find a stack overflow vulnerability. We go through fuzzing and then finding EIP and offset, identifying bad characters to create our shellcode, and then exploiting the program itself. So in section 6, we'll be identifying and exploiting kernel flaws. That's analyzing kernel flaws and exploiting them. We look at a dirty copy on write exploit that actually uses a race condition, and we break down what the kernel flaw is, common causes, how to identify it, how to fix them, and then analyzing that with disassemblers and debugging and things like that. And then the last part for the hands-on portion is going to be our heap overflows. And that is expanding on stack overflows and using these concepts to target the heap data and perform heap overflows. Heap and buffer overflows share some of the same concepts. A heap overflow is a lot more in depth. So we'll be breaking that down a little bit further and going through that. So basically, what these 7 sections do is cover reverse engineering in a broad scope for anyone who is looking to get into this and understand how this works on a Linux system. So it is a 32-bit version, and these give you the primer and fundamentals to expand further as you go into more complex topics with reverse engineering. And then the prerequisites themselves, you need a computer that's basically capable of virtualization for the following OS types. I do use Ubuntu 14.04.1. and then Ubuntu 16.04.6 upgraded to 18.04.6 LTS, and then a Kali Linux version of 2020.1 or greater. With all three of those, the dirty copy on write will need the 14.04.1. You will be able to use that. And because these programs are pretty much written to work on our own, it's not, you don't have to really download anything from anywhere. So we'll use the source code that I've created for the class for you, and you can use it on those machines there. So, but you will need the 14.04.1 and the Kali Linux to do a remote attack on a machine. So the next bullet here would be the background knowledge of basic Linux command is recommended, but not required. So, having an understanding of Linux helps, but I do walk through everything for you through the course. So you're not really expected to know anything. And I try to break it down for anyone who is brand new to this topic. So don't feel intimidated by it. And then any additional information here. This class is designed for you to build your foundation. You do not need to be an expert in reverse engineering. And then all the processes are taught during this course and include everything you need to execute the methods that are to be learned. Like I said, you don't really need too much of a background in this. It does help a little, but you will be able to learn something new. And anybody who already knows some of these concepts, hopefully we'll be able to expand on those with the heap overflows and some of the more complex stuff with format string flaws. Students will be explained what is needed to install as the course goes. So basically, I'm going to walk you through as we go through the course on what to install and that type of thing. The GitHub itself will have the links to the programs and then all the programs that I've written for the course there. So it's pretty simple to get a hold of everything, and it'll be in one spot for you. And then there will be lectures and hands-on training provided during this course of over 4 hours of content. I originally set out to make this course about 4 hours. It did go a little bit longer in certain areas because there's some of the things that I wanted to explain in depth for you, and I didn't want to gloss over it. So I wanted you to really understand how this works and take away some good knowledge from this class. So this is basically wrapping up the introduction to the course. So you will learn the fundamentals of 32-bit reverse engineering and the concepts that are required to be able to do this and kind of catapult yourself to the next level. So hopefully I will see you in the class. Here we go, leading off into section 1.